So we've made a bunch of structures with these pinwheel vertices using a three-way pinwheel vertex. We were able to make a tetrahedron and a cube. Using the five-way pinwheel vertex, we were able to make an icosahedron. Great. And using the four-way, we were able to make an octahedron, and now we're going to make an Archimedean solid known as a cuboctahedron. And there's a illustration of that. Notice how it has four-way junctures. Each vertex is four edges coming together. And like all the other ones, we're making sure that all these pinwheels are spinning the same way. These are all spinning clockwise. You can see by the way the arrows are pointing there. And let's see. Oh, let me deconstruct one of these so I can make it from scratch. A yellow one, just so you can see. Okay, so to make the pinwheel, and you want to make one that's clockwise, you start with one of the hypertiles so that the top and down are pointing towards you. And if we want to go clockwise on it, we want to put the connector on the right side like that, not over here on the left side. That would make it go counterclockwise. And then we just take another one and we connect it and make sure this is a spiral connection, not a zigzag. If you go zigzag, that gets in the way. So, whoops. We want it to be a spiral connection, so like this. So when we fold it, look. And that's what all these do. They fold and get out of each other's way kind of nicely. So that's one. And then we go down to the bottom, add another one. And again, make sure you've got a spiral connection there. Okay, we got a three-way. And now we can go up to maybe this spot here. We've got like 4 spots there. And put this last one on. Okay, and there you have it. As I've been saying in the other ones, you don't have to do this, but it makes it a little bit stronger if you put in a final connector between the first one and the last one, and there's a spot to do that. So that gives you something even stronger. Okay, so there it is. Yeah, I've now got 2, 4, 6, 8, 10, 12, the 12 required vertices, all four-way, and I'm going to start with, I'm going to have my 2 yellows be opposite each other. I did that on the icosahedron. It's just kind of nice. So I'll start with my 3 primary colors, put them like that, and look, there are squares and there are triangles involved in this, so it doesn't really matter. Let's start with the square here. And I can use, let's see what we'll use here. Just 4 different colors is all we need. And by the way, these connections I'm making to make this square are all going to be spiral, but you really don't have to worry about that because that's really all they can be. What I mean by that is all the connections I make here are going to be spiral. The only way I'd be making a zigzag is if I have one of these spinning the wrong way, counterclockwise instead. And look at this here. I've now completed one square. Okay? And it flexes nicely. It does some fun stuff there. And if I were to do just nothing but squares, it would make a big sheet that might kind of have some nice flexible properties. We'll have to try to experiment with that in a bit. But now I want to start making triangles because each square on an octahedron, on a cuboctahedron is surrounded by triangles, edge to edge. So there'll be a triangle here. Maybe I'll put the blue one here. See, now I don't want to make a square, I want to make a triangle. So right there I'm going to join those together. See that? Much tighter there. A triangle, and there's a square. I'll make another one here. And again, I want to put things opposite each other, so I'm going to put purple here. And then I'll put the other purple there. They'll be opposite. That blue one will go there. See how that works? Okay, so once you get these, 12 pinwheels made, this goes pretty quickly. And you don't really even have to focus about whether you're connecting it linearly, in a zigzag or a spiral. Spiral's automatic. So here's my first one that I have to think about being opposite. You don't have to do that color scheme, but it makes some nice symmetry to have the two blues opposite each other. You can see this starting to take on some curvature now, yeah? And that last one here will be purple. Here's a mistake you could make. You could accidentally connect like there. You have to kind of force it. And then you go whoops, and then take it apart because you want to connect with the next one over. Okay. That could happen though. Okay. There we go. And that still flexes through. I can go like that and have it set up now for my 4 remaining ones. And orange opposite will be orange. So I'll put this one here. I'll put my 2 connectors there. Whoops, that was too high. These are completing squares, by the way. I've got my square, 1, 2, 3, 4 triangles. Now we're going to make 4 squares around this. And there's that one. Turn it this way. Opposite green, we'll put the other green. Put in my 2 connectors here. Here's where it's likely to make a mistake. I could have gone like this. And the mistake I made was I got this little extra one in here. So just make sure you're always connecting to the next pinwheel, flap, propeller blade over, whatever. Let's see. Opposite this yellow, I put this yellow. Now it's really starting to close off. Look at that. And last one here. Oh, sorry. I could be making all these connections too. Making little triangles along the way. Let's go ahead and put those in. So when I put that very last piece in, all I have to do is make those 4 connections. So these are making little triangles again. Triangles and squares is all you've got with a Cuboctahedron. I think all the connections are made, and now this one goes right there, opposite the other red one. So pretty straightforward. I'll put these 4 connections on here. And now make these. You might hear these snapping. I'm using an extra firm connector here, but it works with any of the connectors. So there it is. This is, it's kind of hard to see probably, but it is a cuboctahedron made up of triangles and squares, and there's a little bit of play, not much in terms of this, okay? But some of the other pinwheel vertices shapes we made, we could undo a few of these and then invert it, which was kind of cool. With the pinwheel tetrahedron, we could just undo one and it can invert. Some of the other ones took more. This one, interesting. I think I can do it in just 4 along the squares. So there, here, and here. So I've kind of undid them in a kind of a zigzag pattern. And now check out what you can do. You can lay it flat like that, which is kind of neat, and then all the way around and reconnect it. Okay? So that seems to be a nice pattern with these pinwheel structures, is that they can be made to invert. And it is, oh, there's 4 breaks I made. I better make 4 new connections there. Okay? And those are actually the same connections that were there before on the other side. Is this shape the same one I just had? Yes, it's the same shape. And all of these pinwheels are going in the same clockwise direction they were before. But if I'm pretty sure this, I think color pattern wise, this is the mirror image of what I had before, because I just took it and inverted it. And it does have a directionality. I mean, for instance, this goes red, yellow, purple. Red, yellow, purple, red, yellow, purple. As I invert it, those get inverted. So I could be wrong on that. But another cool thing I found out, another way I can invert this, rather than break 4 of these connections, I can break 2, just 2 connections of the pinwheels themselves. So I'll break this red one, and this is going to involve doing that. So I actually broke a vertex now, and then a neighboring one. How about this green one? And because I connected it all the way around, I am breaking still a total of 4 connections. 2 got broken there, and let's see if I can do this right. 2 there. They're still holding together with the remaining ones, but ready for this? Oh, that's beautiful. So that lays nice and flat. And in case you're curious, where are those triangles? The triangles are still all intact. I've got some coffee stirs held together by twist ties. 1, 2, 3, 4, 5, 6, 7, 8. All 8 of my equilateral triangles are intact. Where are my squares? Here, we'll modify this into a square. My squares are, remember there's supposed to be 6 of them. They're here, but they're distorted into rhombuses. Rhombi. 1, 2, 3. A 4th one is kind of here over to here. That's where I broke it. So that's 4 of them. Wait, where's the 5th and 6th? They're across the top. So I guess that'd be like this, connecting when I connect the ends. So it's kind of neat. All 8 triangles are there. Only 3 of the squares still remain intact, and they've been converted into rhombuses. So anyway, like this, and then like this, okay? Reconnecting these is a little bit trickier, but it's doable, okay? So we'll just connect them loosely there. There it is, the Pinwheel cube octahedron.